Here we go. What we've been looking at is using combinations and combinatorics to do probability questions. And here's what I said last day, but apparently it bears lots of repeating. If you want me to pick two things, tree. Three things, maybe tree, maybe not. Anything more than that, combinations, combinatorics, some kind of a bucket approach. So looking at this example here, it says, a bag of marbles contains 5 red, 3 green, and 6 blue marbles. Suppose a child randomly chooses how many marbles? How many marbles? 3. I don't think I want to do a tree here. Okay? So, you know what? Since all of you look a little dozy, since we're doing since we're trying to brush off the cobwebs, since we're doing some review, since I'm grumpy with you, all of us underline the word 3. And the second issue is, which means the odds are going to be changing each time you pick a marble. That's when your best strategy is a bucket. A bucket. So, Jacob, can you read to me A? It says find the probability that what?
Exactly 2 are blue.
Okay. How many marbles are we picking? 3. That's why this is a tricky question. If they had said all 3 were blue, I could probably do that with a tree by just drawing that single branch. It would be blue on the first, blue on the second, blue on the third. I would have 1 less blue each time I move down and 1 less marble each time I move down. And I'm moving down, it'd be multiplied down the tree. It'd be 1 blue and second blue and third blue. But the fact that they're saying 2 blue, 1 not, that means, Brooke, you could have the first one not blue and the next 2 blue, or the first one blue, the second one not, the third one blue, or the first one blue, the second one blue, the third one, it's too much to keep track of. Bucket. What's it going to look like here? What do they want? Again, can you read to me A, please, Jacob, my friend?
Exactly 2 are blue.
Blue and not blue. Because all they're talking about is blue, I don't think I need to worry about having red and green as separate containers in my bucket. I think what I can just say is, blue or not. How many blues are there in the bucket grand total? How many non-blues are there in the bucket grand total? How many blues do I want to choose here for this question? How many? 2. And since I'm picking 3 marbles, how many non-blues must I end up choosing?
1.
So what's it going to be? My equation, the probability of exactly 2 blues is going to be from 6 blues, not permutate, Mr. Dueck. From 6 blues, choose 2 of them, and from 8 others, choose 1. Now that's how many different ways there are to pick 2 blues. To turn it into a probability, we said probability was defined as the number of successes divided by the total number of outcomes. How many marbles are there grand total? 14. Choose. How many am I choosing? 3. And we said this, there's a built-in error check. If you do it right, this plus this should equal the front number. Last number plus last number should equal the last number. Do that? That's my built-in error check for these. Now it's time to go to my calculator, and these answers I almost always get as a decimal. Probably could do it as a fraction, but I tend to go decimal because it's going to be option, arrow sideways, probability, 6, choose 2, and 8, choose 1, divided by 14, choose 3. Well, give it to me as a fraction. 30 out of 91. Or, as a decimal, 0.3297. About almost, but not quite, 33% chance. Just shy of that. Okay. Why did I use choose? I don't think the order mattered here. Now, compare that with B. What does B say? First is red, second is green, the third is blue. Here, I think you'll agree with me, Kayvon, the order matters. So don't use choose. Don't use NCR. How can I do this one? If they give me the order, even though there's 3 marbles, if they give me the order, when they give me a specific order, I can visualize one tree branch. I'm going to sort of, kinda use a tree. But I'm not going to draw out the full tree. And Brooke, the only reason I can get away with that, you understand, in the previous one you heard when I said, since they just said 2 blue and 1 not, there was all those different possibilities. When did I get the non-blue? On the first marble or the second marble or the 3? That's a lot of drawing and a lot of or means add. Here, because they gave me the specific order, I can visualize one tree branch. It's going to look like this. The first one, it says, is what? Red on the first. Can you fill in the fraction that would go on this tree branch? How many reds are there in the bucket, in the bag? How many reds are there grand total? Out of? Okay, so I can say the probability of getting red the first time is 5 out of 14. I got a red. What does it want on the second level? Hey, I can even change colors. Green on the second. How many greens are there? Out of? Don't say 14, careful. Ah. Is it 2 out of 13? 3 out of 13? I was kind of wondering, going from memory. What do they want me to pick on the third draw? Blue? So this is going to be blue on the third. How many blues are there? 6 out of? So, Seb, I'm kind of cheating here in that I've said to you, well, when there's 3 or more, I don't do a tree. You know what? If there's 3 or more, but they give me a specific order, there is a way to do this using NPR, using permutations. I find it just as easy to visualize, because I got a good imagination, walking down that specific branch, because it's only one branch that will satisfy when there's order matters. By the way, it's the first is red, and the second is green, and the third is blue. Sebastian, what am I going to do with these 3 fractions? Multiply. So it's going to be this. The probability of red 1, comma, green 2, comma, blue 3, and it's going to be 5 out of 14, and 3 out of 13, and 6 out of 12, which is what? You can either go top times top times top over bottom times bottom times bottom, or you can use your fraction button on your calculator and get an answer in lowest terms. I don't care which. What do you get? I'm going to use the fraction button. 5 fraction 14 times 3 fraction 13 times 6 fraction 12. Do you get 15 over 364? Or am I wrong? Yes? So when I say what do you get, next time you guys can say that, 15. Or if you want it as a decimal, 4%, 4.12%. Are the odds of that occurring, is the probability of that occurring very high? Nope. If that was a game, would you pay money to play that game if you were gambling? Not unless they were really rewarding a huge prize, but probably not. Okay. What's the difference between B and C? Okay, in C, they don't care about the order. Now, here's what that means. In C, you could go red, green, blue, or red, blue, green, or blue, green, red, or... Since order doesn't matter, here, and I'm picking 3 marbles, a bucket is going to be my best bet. Here, a bucket is going to be my best bet. It's going to look like this. I have red, green, and blue. How many reds are in the bucket? How many greens are in the bucket? 3. How many blues are in the bucket? 6. How many reds do I want to choose? 1. How many greens do I want to choose? 1. How many blues do I want to choose? 1. So the probability of red, green, blue, in any order, is going to be what? 5 choose 1, and 3 choose 1, and keep going, Rosanna. And that's how many different ways that I can pick a red, blue, and a green. It's okay. By the way, small shortcut, I think 5 choose 1 is 5. I think 3 choose 1 is 3. I think 6 choose 1 is 6. So if you're really lazy, you could just go on the top, 5 times 3 times 6 over 14 choose 3. Because if I recall, the choose 1s were just that number, right? And a choose 0 was always a 1. I get... well, as a fraction, 45 over 182. Or as a decimal, 0.2473 if I round off properly. How is D different from A? How is D different from A? Sorry? Say that loudly, please, Tiff.
You want at least 1 blue, so you have 1 or 2 or 3.
Okay. And what does or mean? At. So Tiff is suggesting at least 1. That means and she is correct. Does anybody see a better way to do it, though? A shorter way to do it? What's the opposite of at least 1 is blue? None. I think the other thing you could go is 1 minus none, which would only be drawing 1 bucket. Let's do it the long way, and then we'll see if the short way also works. So over here, and because all they're talking about is blue, I'll go blue and not blue. How many blues were there in the bucket grand total? 6. How many non-blues? 8. Or means add. Or means add. This is going to be a huge uber fraction, big long fraction. Let's do 1. So if we want 1, how many non-blues? 2. So let's write here, what choose what choose what? 6 choose 1, and 8 choose 2. Now I'll scribble out the 1, I'll scribble out the 2. Let's do 2. So that's going to be 2 and 1. So 6 choose 2 and 8 choose 1, or 3 and none. 6 choose 3 and 8 choose none. So there's 1 or 2 or 3 divided by what? 14 marbles, choose 3 of them. Now, Mr. Dueck, I thought you said when you add up, if you add up the front for this first little group, it matches. Add up the front and last for this group, it matches. Add up the front and last for this group, it matches. That's still your built-in error check. So let's go to our calculators and let's type this in. Is there more than one number on the top? I better put this top in brackets because there's plus signs. Bracket. 6 choose 1 and 8 choose 2, or 6 choose 2 and 8 choose 1, or 6 choose 3 and 8 choose none, over, is there more, oh, just one number in the bottom, 14 choose 3, just one expression in the bottom. What do you get? Double check your brackets. Is that right? Or as a fraction, 11 out of 13. Oh, those are good. That's a good probability. (11 out of 13) or 0.8462. Okay. Poker. Turn the page. Oh, you want to try the complement? Thank you, I forgot. So that would be 1 minus the probability of 0, which should be 1 minus from 6 blues, choose 0, and from 8 others, choose 3, all over 14, choose 3. Let's see if that gives us, right, that would be 0. No blues, 3 others, 14, choose 3. Let's see if that works. 6, choose 0, and 8, choose 3, divided by 14, choose 3. Oh, syntax error. 14, choose 3. 1 minus that. Do you also get 0.8462? Same answer. Which one's right? They both are. Rosanna, I tend to be lazy, and so if you're looking at when I give you guys the great big probability review, you'll see often I'll use the complement as a shortcut if you're looking at my work, because online there'll be an answer key showing all my steps, but either way is fine. Now let's play poker. We're going to do 5-card poker, because that was what was popular when I first created these. I know Texas Hold'em 7-card poker is very popular right now. It's not that hard to extend it to 7 cards. Your buckets get bigger is all. So, in a card game, 5 cards are chosen from a shuffled deck of 52 cards. What's the probability that the 5-card hand contains A? 4 aces. First of all, 4 aces, is that a good hand or a bad hand? So are you expecting a high fraction or a small fraction? Small decimal, small fraction. Okay. How many cards are we choosing? 5. We could do this as a tree, but you understand, if you did this as a tree, because you're picking 5 cards and you want 4 aces, you'd have to do a tree for the 4 aces first and then the other card, or 1 ace, the other card, and then 3 aces, or 2 aces, the other card, and then 2. You have to look at every possible option for where the ace, for where the non-ace shows up. How many cards are we choosing here, Brooke?
4.
How many cards are we Sorry?
5.
5, bucket. Okay. 2 cards, tree. 3 cards, maybe tree, maybe bucket. 5 cards, bucket. So what's my bucket going to look like here? Ace, non-ace. How many aces are there in the deck? 4. How many non-aces? Thank you for using the complement and not counting. How many aces do I want to choose? How many non-aces? Got to pick one because I'm picking 5 cards. Right? Probability of 4 aces. Looks like it's going to be 4, choose 4, and 48, choose 1, over what, choose what? From 52 cards, choose 5 at random. This may give you an answer in scientific notation. I'm not sure. I know it's going to be pretty small. 4, choose 4, which is really just 1, times 48, choose 1, which is really just 48, divided by 52, choose 5, which was, I think, 2.6 million or something like that, I seem to recall. Yeah, I'm getting an answer in scientific notation. Are you guys getting a decimal, or are you guys getting an answer in scientific notation? You getting a decimal? Okay. In scientific notation, those of you that are in physics or chemistry, hopefully this is kind of a walk in the park. I'll write down 1.847 times 10 to the negative 5, which means 0.1234 zeros. Negative 5 means the first non-zero digit starts 5 numbers after the decimal point. 847. What do you call it, by the way, when you get 4 aces? When you get 4 of the same card, what's that called? Jordan. Okay, this is 4 of a kind for aces. How many different ways are there to get 4 of a kind? How many different cards are there? 13. If you want to find the probability of getting 4 of a kind, it's that number times 30. There's the probability of getting 4 of a kind. Okay? B, 4 tens and 1 ace. Now this is 4 of a kind, just like A, except I added one more condition. I said, oh, and I'm also going to tell you what card I want that last card to be. 4 tens and 1 ace. How many cards are we choosing, Kayvon? Grand total? Bucket. What's my bucket going to look like here? Aces, tens, and others. Right? How many aces are there in the deck? How many tens are there in the deck? What's left over? Whatever 52 take away 8 is. 44? How many aces do I want? Careful. Just 1. How many tens do I want? 4. How many of the rest do I want? It's a trick question. So it's going to look like this. Get your ace. Get your tens. Don't pick any others. All over. What choose what? Now look up for a second, everybody. A lot of textbooks won't bother putting this term in because 44 choose 0 is just 1. So a lot of textbooks won't bother having that little bit there. The reason I like it is I've told you I kind of like that built-in error check. Double check. Is 4 plus 4 plus 44 52? Yes. Is 1 plus 4 plus 0 5? Yes. Having said that, if you don't write a choose 0, I'm not going to mark you wrong or anything like that, because it is an unnecessary step, and this is one of the few times that I'll ever write an unnecessary step. I just like the symmetry built-in error check of it, because I'm not quite certain on some of these questions. It's my built-in safety net. Do you have to write it? No. Four, choose 1. And 4 choose 4, and 48 choose none, divided by 52 choose 5. This is an even smaller chance because, this is an even smaller answer than A, because in A you were just saying 4 of a kind, in B you're saying 4 of a kind, oh, and I'm going to tell you which other card I want, which makes it even more unlikely. I get 1.539 times 10. 1.539 times 10 to the negative 6, or 0.123451539. C. 10, Jack, Queen, King, Ace. What do you call this hand here? Yeah, it's a straight, because I didn't just define suits. If it was all in the same suit, that's the best hand. It's called the royal flush. Means you've got all the same color and all in order. That's the best hand. As far as I know, no hand beats that in 5-card draw. Here, we're just saying in that order, but they could be hearts or diamonds, so I don't care. Okay. How many cards are we choosing? 5. Bucket. What's my bucket going to look like here? It's going to be a fairly long, lengthy bucket. Yeah, it's going to look like this. I'm going to have a compartment for tens, jacks, queens, king, aces, and others. How many tens are there in the deck? How many jacks? 4, 4, 4, 4. Uh-oh. How many others? 52 take away what? 52 take away what? 52 take away 20, which I would argue I can do in my head. 32, yeah? Try this one on your own. I'll do it up here slowly, but I won't say anything. I got clever. Since I was going 4 choose 1, 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 I said, hey, that's the same as 4 choose 1 all to the 5th power. You don't have to do it that way, but I'm lazy. Come in. Do you get 3.94 times 10 to negative 4? No?
I got that.
Yeah? Okay. Do I need to write them as decimals, or are you guys okay with scientific notation because you've done science? I'm going to say I'm a 0.000394. But if your calculator gives you something in scientific notation, because most of the hands that are interesting have very poor odds of occurring, you're going to get some small numbers here. Sorry. Who told me, what do you call this? A straight. How many different ways are there of getting a straight? Well, you can start with a 2 and you can go 2, 3, 4, 5, 6. 3, 4, 5, 6, 7. 4, 5, 6, 7, 8. 5. You can start with a 5. You can start with a 6. You can start with a 7. You can start with an 8. You can start with a 9. You can start with a 10. You can't start with anything past that because you'll no longer get a straight. How many ways are there of getting a straight? How many ways are there of getting a straight? So if you multiply that number by 9, that's the probability of getting any straight. So if you're wondering how they figure out the gambling odds, if you ever watch gambling on Sportsnet or whatever, where they're showing you the Texas Hold'em odds and they have little percentages whenever they show the person's possible hands and the probability of them winning, they're using a computer to calculate all the possible outcomes and which ones are higher and which ones are lower. But they're doing this just really fast. D. At least one jack. At least one jack. What does at least one jack mean? Or? Can we have 5 jacks? Okay. And I would have no problem if you went 1 or 2 or 3 or 4, but I'm going to say, you know what? What's the opposite of at least one jack? 0. I think it's going to be way easier to say this. 1 minus the probability of 0 jacks. One minus, are you ready? This time only, we're going to see if we can do the bucket in our heads. On a quiz, on a test, I would never try doing the bucket in our heads, but just to show you that it can be done, we would say, visualize the bucket. We want jacks. How many jacks do we want to pick? First of all, how many jacks are there? Choose, how many do I want to pick? And how many non-jacks are there? 48. Choose, how many do I want to pick? 5 over 52. Choose 5. Roy, I would never on a quiz or a test do the bucket in my head, but for what it's worth, I guess it's doable. It's going to be 1 minus 4, choose 0, and 48, choose 5, divided by 52, choose 5. By the way, is it likely that if you pick 5 cards, at least one of them will be a jack? Fairly. So I'm not expecting like a 10 to the negative 6. I'm not expecting even a 10 to the negative 5. Oh, a 34% chance that if you're picking 5 cards, at least one of them's a jack. 0.3412. That kind of bugs kids. They say, Mr. Dueck, that seems kind of high. That's saying there's a better than 1 in 3 chance. That almost suggests that 1 in 3 cards is a jack, Mr. No. Not saying that, because there's only 4 jacks in the deck. But because you said at least, what you're saying is, oh, you could have 1 or 2 or 3 or 4. Those ors add up and slowly make this number bigger and bigger and bigger and bigger. make it more likely to occur. And that brings us to a very, very famous mathematical problem. It's called the birthday problem, and it's very counterintuitive. And I'm going to start out by offering to make a $1 bet with anyone. And here's the $1 bet. I will bet anyone $1 that in this classroom, 2 of us were born on the same day of the year. At least 2 of us were born on the same day of the year. Anybody want to take me up on that bet? $1. Got to have a loony. Okay, you got a loony on you. Got to prove it.
It's in my car.
It's in your car. I'll say the bet again. So the bet is I will bet anybody $1 that in this class there are at least 2 of us that were born on the same day of the year. Roy, you in? You got a loony on you?
I got $1 right here.
You got $1? Roy, you in?
Yeah.
Okay. So we're going to perform the experiment.
In or out?
You don't have the money on you. Right? What's your homework? Well, I'm giving you lesson 6 homework, and you have lesson 5 homework. Some of you guys know Friday is a Pro D day. You have a long weekend coming up. I will probably, knowing how I roll, on Thursday night send a fairly fiercely worded email home to your parents saying that if you haven't got everything handed in, you're working Friday all day on my homework. That's the choice you have made. So what's the lesson 6 homework? Give me 1 second. So what's your homework? Take a look at lesson 6 here, please, or the handout lesson 6 homework that I just gave you. The answers are attached. Here's my approach. First of all, say, for example, looking at number 1. Number 1, you're just doing 1 marble. You can do that using a tree, or you know what? The whole bucket thing does work with 1 marble too. You can use a bucket if you want to. Number 2 says use the multiplication law or use permutations or combinations. In other words, in number 2, you're picking 2 marbles. 2, you can do a tree or you can use a bucket. This one's saying to do both. Now, here, order doesn't matter. Here, order matters. Draw the tree or the tree branch. Blue on the first, yellow on the second. You don't necessarily need to do the entire tree. You can do that with permutations. I'm not a huge fan of using NPR for probability. I'm not great at it. I make mistakes. So if you can figure out B part 2, great. I tend to, and I've already told you, my fallback, Ellen, is when I'm not sure what to do, I try and do a tree. Especially if they mention something to do with order. Okay? Number 3, you're picking 2 marbles from a box. Again, tree, or you know what? We're practicing using the bucket thing, so try doing it with a bucket. If you're not sure, you can use a tree. Certainly, when you get to number 5, 3 prizes. I'll let you think about that here, how to do that one. Toys selected, jars, and then I put more questions on the back because I think most of you are more interested in card and poker and gambling questions. So, suppose 5 cards are dealt. Find the probability that a card hand contains 5 diamonds, what we call a flush. 4 diamonds and 1 other card, 4 diamonds and 1 heart, 4 kings and 1 other card, 4 kings and 1 queen, 3 aces, 1 king, and 1 other card. And based on these answers, which hand is better in poker? Hand number 1, a diamond flush, or hand number 4, 4 kings? In other words, which one has the smallest probability? That's the better hand. So now you can start writing or regenerating the rules for poker. You almost have all class to work on this, but not quite. I got something else I'm going to give you right now.